Hey guys, this is Jeff Riddell. Today we are talking about ventilation in silos and the project I did to control those silos. So this project is about from my mobile phone looking at the weather forecast information, controlling weather automatically as much as possible using smart data, the ventilation fan of a storage silo for grains, whether if it's corn, soybean, or wheat. So if we look into what's available so far is, first of all, just walk to the bin, turn on the switch, and get that fan running for the time being. But this is a pain. I am 7 minutes away from the farm, so going up there and back, this is far from being efficient. So most of the time, I just call my dad, go and turn on the fan, and that is not pretty appreciated. So there are solutions to do it. One of them is AgriLog. You can see their interface. This is a gorgeous application. It's a little expensive though. There's GSI with their Bullseye solution. Again, it's roughly the same thing with sensors inside with a controller. There's other companies like Adaptive Agriculture. They also have some of those types of fancy sensors you're rolling into the silo to make sure that this is controlled in the best environment you can think of. And there is also GrainViz. So GrainViz is pretty much like the CT scan or the MRI scanner of the silo bins out there. So this definitely blown my mind. They are installing these kind of antenna sensors that are, I believe, sending magnetic wave in order to feel what is the density and the moisture content of the silo and build up that really 3D map of what's in there. Well, this gotta be expensive, but into my case, where I just have like 100 or 200 tons of grain per silo, it doesn't make much sense. So I decided to build my own. And using a Raspberry Pi, it's actually not that hard. A Raspberry Pi is pretty much just like having a laptop computer or a PC within this little board with all these pins out that allows you to control and receive information from sensor. Within the Raspberry Pi, you have office tools, you have programming tools. Even the browser is perfect. um, Believe me, this is such a cool tool, and adding the relay board. In this case, I can control as much as 8 motors, and altogether with the shipping, it was something like $150. So this is super cheap. But keep in mind, this is not CSA approved. Therefore, there are some extra care that have to be taken in account, especially for insurance purposes, probably. So let's be careful with these things. On the programming side, I've used Node-RED, which is also a part of the Raspberry platform. It's free of charge. It is based on a tool set we have on the side here that we're drag and dropping in our worksheet. And we're just double clicking on every of these boxes to set up whatever tools we need and connect them in between. Automatically, there is a control panel which is produced from this. Of course, there's tons of setting for whatever we need to do, but bottom line is this has been so simple to implement. One other aspect I wanted to touch here is that usually if we look to other solutions like AgriLog and Bulleyes, they are cloud-based. So from your computer, anywhere in the world, you access a cloud service, which is connecting to your sensors on your silo and eventually controlling as well the ventilation. So this cloud service usually have to be paid. In my case, I wanted to have something as low cost as possible. So I had to open a backdoor in my router of my network so that I can directly connect my router, which is then connecting me to my Raspberry Pi. And therefore, I also had to figure out what was my public IP address. It's nothing that fancy, but these steps are pretty important. Now, if we go back to the theoretical understanding of moisture content in a grain, it is based on those charts. So you've got humidity and temperature, and depending of those two parameters, we have to figure out what's going to be the best range for our corn. And if we say it in a different way, if you have a temperature of 70 Fahrenheit with 55% of moisture, and you blow it forever, the moisture contents you're going to get in your grain is 12.6. So this is what we call also an equilibrium or an EMC. So from that previous table, if we transfer it into Excel and we plot every of those moisture line, this is the type of graph we're getting. And on my software, I wanted to have as much accuracy as possible. So from those curves, I've synthesized those curves into quadratic equations. That looks a little bit fancy, but why not? It's cool. And I've output these equations for every of those lines, creating a vector, and we're going to see it after that. Here is one equation, and you can see that we have a certain amount of reference, and therefore we'll have to do interpolation. So these are the vector I was mentioning about. This is the interpolation equations, and here is the final quadratic equation to generate our equilibrium information based on temperature and outside humidity. So we are getting the outside and humidity from the weather information. This information is cleaned and then fed to my equilibrium computers algorithm. And let's see, yeah. All right, so let's move on. And here's the panel which is generated by the system. You can see we have the current equilibrium. So at 18%, it's not a good time to try to dry the grain for sure. So the system is stopped. I haven't used them for a while, so all these data are off. And here's some graph you're getting out of this. And on the side, this is the dashboard that I'm getting from my mobile phone. This is the control side where we're choosing the grain we have in the bin, an upper limit for ventilation, lower limit of ventilation, and minimal temperature. So pretty straightforward. That roughly allows us to do most of it. Eventually, in grain storage, we might have to cool down grain. So regardless to those parameters, it'd be cool actually to have another option to say, well, let's just ventilate for 2-3 hours to cool down the silo. So that's going to be a future development. If someone would be interested in developing that, that'd be so appreciated. Talking about future development, here's an amazing sensor from Bosch who does temperature, humidity, pressure, and gas contents. Gas contents is actually carbon related things such as CO2 or alcohol. So if we'd have fermentation or burning in the silo, we should be able to figure that out from this sensor. Now, this sensor is driven through an I2C bus. I2C bus is rather good for within a few feet. Now, we have to be 30 meters away to put that sensor on the top of the silo. So there's communication issues that could be there. Anybody with expertise to fix these would be much appreciated. However, using Raspberry Pi, it's pretty Raspberry Pi and Node-RED, it's pretty cool because we already have the drivers to connect to this, so it's pretty straightforward when we get it to work. But again, as we get communication error on a long distance, the driver kind of crashed there. So this is one more thing that have to be fixed in the future. One other interesting we could do with this is pressure. We should be able to measure the pressure difference between, let's say, outside, inside the silo, or eventually if we put one further down the silo, we'd be able to measure the pressure difference, whether if we're getting the right ventilation through this. And also being able to do the difference between humidity at the bottom and humidity at the top. That should allow us to figure out if our grain has been dried and if we're pulling out some moisture out of the grain. And one other thing which would be nice to use in this development is using such a psychometric metric chart to actually figure out what I was just talking about with moisture content in the air, which is pulled out or pulled in. But this requires a little more math to be implemented. I believe that solutions such as AgriLog and Bulleye have such algorithm inside. I may remind you guys that I'm selling AutoSteer solutions, actually from Alinav. If you have any question about that, please feel free to call me. But before closing this video, I remind my goal here is to encourage you guys to learn about automation, get control of your system if you can, if you're wishing to, and eventually if this can be an open source development project, that'd be so cool. And hope it was appreciated. Looking forward to get news from this system. And if you'd like to have the source code, just let me know. I'll be happy to share it.